Hello everybody and welcome back, and let's continue with connecting back to our Kali Linux machine. So what we're going to do right here is something very interesting. You remember the jump variable or the jump statement in the while true loop in our server, the one that we used in order to actually jump in the while true loop from one spot to another, where we're going to use the same thing right here. So we're going to perform the same thing, just in this case we're going to call it start, and we're going to code it outside of the while true loop, and you will see just in case why we're doing that. So what we're going to do is we're not going to perform a while true loop, we're going to perform a while connect loop. So what this means, and let me just code it right here and then I will explain it. So connect sock, and then we're going to perform the connect function struct sock addr pointing to, let me just see right here, address of server addr and the size of server addr. And then we are going to make that to not be, or to check whether it is not equal to 0, and open these brackets right here. Don't worry, I will explain this. Let me just code it, sleep 10, and then go to start. So this is basically it, but right now let us explain it. So we coded this start part right here, which we're going to jump to in this statement right here. But we're going to perform while, and then while the connect, so while the connection to the actual Kali Linux machine is not established, if it is not established in this actual line right here, then we're going to sleep for 10 seconds, and then we're going to go to start once again, which is going to lead to the next line, which is going to be once again the connect function, which is going to check whether we can connect right now. And if we can't connect even then we're going to sleep once again for 10 seconds and go right here. And if from the third time, for example, we manage to connect, then we're going to skip this while true loop and proceed to the actual shell, which we're going to specify right here. And then we're going to code the shell function. So simple as that. This is really easy to understand. We're simply just going to perform the connection every 10 seconds until we manage to connect. So right here, let us go and create another function. So make sure that you code it with capital S right here as well. We're going to code the void shell function, and the reason we are using void is because we are not returning any value from this function, therefore we can specify it as void. And now we're going to define some different variables like we did in server that we're going to need throughout the actual shell function. So the first one is going to be the char buffer, which is going to accept 1024 bytes. The second one is going to be, let's go with the total response, and that's going to be the total response of the entire command execution, which is going to take a lot more bytes. And in this case, let me just save it a little bit and go to this server. Let me see how many bytes we're going to define to that one right here. Since we defined in our response, which is going to take the entire response to be 18,384 bytes, we're going to copy that. And since the total response from our malware is equal to the response from our server, therefore the total response right here should have the same amount of bytes. So that would be right here. And we can do something like this, define an error, but we don't really need that right now. We're going to code it if we do need it, and let's jump right into the while true loop. Now the reason why I'm going through this part of the program this fast is because we already did it in our server, therefore nothing really to explain right here. And let's right away type the jump function or the jump line right here, which we're going to use when we need to go to the beginning of the while true loop. And at the beginning, like we did in our server, we are going to perform the B0 because we defined it right here. We can perform it. We're going to perform it on every variable that we have right here. So the B0 is going to be performed on buffer, and the size is going to be 1024, or we can simply just do size of buffer so you don't get confused. So size of buffer. The second one is going to be path, and then the size of path. Simple as that. And the last one is going to be the b0 from the total response and size of total response. Simple as that. So we perform the b0 function on every variable that we have, and right now we are ready to receive the command from our server. So how we can do that? We can do that simply just by typing receive function, and we want to receive from our socket. We want to receive the buffer, or we want to store it inside the buffer. Size of buffer is going to be the amount of bytes that we're going to accept. And the last one, which is the flag, is going to be 0. We don't want to set any flag. Therefore, we're going to receive our command from the server and store it inside a buffer. Okay, simple as that. Let's go down here. And right now we're going to perform the same things that we did in our server. So first of all, let us compare if the command that we got is equal to Q. So string compare. We want to perform Q right here. We want to perform with buffer, and we want to perform the comparison of the first 1 byte. If that is equal to 0, then we are going to simply just close our socket. Simple as that. Close this socket, since we are actually closing the connection. So close socket. We also need to perform something called, to close it properly, we need to perform something called WSA cleanup, because as you can see right here, we created the WSA data, so we want to perform the WSA cleanup function, and we want to exit out of the program. So simple as that. If string compare equals to Q, so if we get the Q command, we're going to close our program. So nothing really right here to explain. Let's go in any other case. We want to actually execute the command, so else, and then we're going to create something as a file pointer, so file and then star, and then we are going to call it fp. And what we're going to do with this, we're going to use it in order to execute the command as a process. So we can do that simply just by using fp equals and then underscore p open as a process open, and then we want to open whatever we got in the buffer. Therefore, we're going to specify open buffer. So for example, if the command that we received was who am I, it will be stored in buffer. Therefore, we can simply just specify it as a buffer, because it is going to represent any command that we receive. And we want to perform the read function, or the read actual option on this actual command. So we want to read whatever we got from the response to this command. We're going to store that into a total response. And how we can do that? So while, and then while f gets, so while we get the string, let's get it to the path. Let's get every 1024 bytes, and let's get it from the fp. So as we can see right here, what fgets function does. So let's just type fgets, go right here, C library function fgets. The C library function reads a line from the specified stream. So it will read a line from this specified stream, which is going to open up a process and execute it. And stores it into the string pointed by str. It stops when either n-1 characters are read, the new character is read, or the end of file is reached. So right here, parameters are str. So the str in our case is the path variable, and this is the pointer to an array of characters where the string read is stored. So we want to store this into a path, and you will see just in case why we are doing that. The n value, or the size of the actual path, is going to be the maximum number of characters to be read, including the final null character. Usually the length of the array passed as string is used. So you simply just usually specify the actual size of the string that you're using to store the actual value. And the last one in our case, which is fp, or the stream, this is the pointer to a file object that identifies the stream where characters are read from. So this is the pointer to this file object where we executed the actual buffer command, and therefore reading its result. So while f gets 1024 bytes from the fp stream is not equal to null, so while it is still reading something and it didn't come to the end of the actual command, what we want to do, use a function called string cat, and what this function does is it will concat a string onto another string. And what we want to concat is we want to concat to the total response we want to concat path. So what simply this means, I will write it right here. So let's say from the first run we get, for example, hello, and then in the second run we get world, and then in the third run we get hello once again. What this will do, what this actual while true loop will do, is it will simply just concat these three strings onto one another, and therefore our total response will be equal to this. After we finish this, after we store the entire result of the command into the total response, now we can send the total response back to Kali Linux machine. So send over the socket, comma, we want to send the total underscore response, and we want to send the size of total underscore response. We also want to set the flag to be equal to 0 because we are not specifying any, and after it we need to close the actual pointer to our file, or in this case close our file, and we want to close it with fclose function onto the fp. And that's what we performed, and right now our actual Kali Linux machine should receive the actual result from the command it sent to the target machine, and therefore this will go to the beginning of the while true loop, it will delete or it will zero every variable that we used, and it will once again wait for a second command to execute, while our server will print out the response from the first command, and then it will prompt once again for the input for the second command to send to the server. That will be basically about it for this program, but in the next video first of all we're going to test this program, and then we are going to notice a little bit of an error or a little bit of a problem that we have. We're going to actually need to code another function that is going to help us solve that problem, but more about that in the next tutorial. For now on, this will be about it. So let's save this, and in the next video I will show you how you can compile it and test it, and then after it we're going to code that function that we need in order to solve that problem of ours. So hope you enjoyed this tutorial, and I hope I will see you in the next one. Bye.